Good everyone, my name is Mr. Ademujimi Adedotun. What we're looking at today is what I call friction. Friction. What do we mean friction? Friction is relative oppose. Friction. Friction is what I call what? Relative motion oppose. Relative motion oppose. That is, the function of motion friction is to oppose the relative motion. Oppose the relative motion. Relative motion oppose. Relative motion oppose. Okay? Let's say for instance that we have a body A. We have body A. Body A and another body B. Okay? So there is a force attached to what? To body A. A force F to pull the body toward this side. There will be a frictional force opposing the direction that is the movement of a body A. Opposing it. Opposite to what? To the force. That would be what? The frictional force. On what? On A. Due to what? Due to B. Frictional force on A. Due to B. Frictional force on A. Due to what? Due to B. What about if we try to what? To pull B with a certain force? There will be a frictional force also opposing this. Okay? And that will be what? Frictional force of what? Of frictional force of B due to what? Due to A. Due to A. Due to A. So friction means relative oppose. That is relative motion oppose. Friction opposes motion. It opposes motion. Okay? It opposes motion. It opposes motion. Under this, we have types of friction. We have types of friction. Types of friction. Types of friction. Types. We have static. Static. And what? And what we call what? Kinetic. Kinetic or dynamic. Static friction and dynamic or kinetic friction. When you say static friction. This is kinetic or dynamic what? Friction. When you say kinetic has to do with what? When a body is in what? Motion. When body is moving, that is kinetic. When you say what? Static, that is friction at what? At rest. When a body is what? Is at rest. Say such body is what? Is static. Not moving, that is at rest. At rest. At rest. That is static. Static, or when the force applying to the body is equal to the friction. Okay? When the force applied to the body, let's take for instance that we have what? We have body A and we have force F applied to it. There will be a what? A kind of what? Opposing what? Force. That frictional force. Opposing the what? The movement of what? Of the body. Opposing it. Opposing it. This is ground. Let's take for instance that this force is 6 Newton and the frictional force is also 6 Newton. Then this is what? Is static. 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 That is at where? At rest. At rest. when the body is not moving, or when what the force applied balances the frictional force, then it's static, not moving. You're trying to pull a car, you are pushing it and the car is not moving. Then it means that what the force that you are applying is either is less than or equal, okay, to the frictional force of the object or of the body. That is friction. The relative motion opposes. It opposes the relative motion. Types. We have static friction and kinetic friction, or you call it dynamic. What do you mean by static friction or dynamic friction? When you say dynamic friction has to do with when a body is the minimum, or you can say the maximum force, or the maximum force that is required in order to for a body to begin to move over another body. Okay. The force required or the force needed for a body to begin to move. Or you say tendency. You say relative motion is there. In this, when you have relative motion is there. When relative motion is there, relative motion, okay, that is kinetic or dynamic. The tendency, this one is tendency of what? Of relative motion is what? Is there. The tendency of relative motion is there. That means the body is what? Is at rest. Is at what? Rest. This is what? Motion. When the tendency of relative motion is there, that's motion. That's rest. Motion. Okay? Or we can say that static friction is the maximum force required maximum force is the maximum force required for a body to move over another body. That is static friction. Is the maximum force required for a body to move over another body. Or you can say the tendency of relative motion is there. Okay. While kinetic or dynamic friction is the force required for a body to move with a uniform speed over another body. Okay. Example of this is rolling motion or rotating motion. When you have two parts moving, that is rotating motion. Example of that is what we call kinetic friction. Kinetic friction is the force required for a body to what? To move with a uniform speed over another body. Or with a uniform what? Speed. Uniform what? Speed with another body. Or we can have this as, is the maximum force required for a force to what? For a body to what? To begin. For a body to begin to move over what? Over another body. Over another body. Begins to move. Okay? That is static. Static. That means rest. When body is at what? At rest. Means it's static. That is when the force applied is equal to what? To the frictional force. It means that the body is what? Is static. It's not moving. It's at rest. Okay? Static. Static frictional. Static friction. Static friction. In static friction, said when the what? The tendency, when the tendency of relative motion is what? Is there. That is rest. When the tendency of relative motion is there, that is static. First. Second part, static friction. Static friction is what? It varies. That is variable. Static friction varies, not constant. Varies. Static friction is variable. That is what? Variable. That is in static friction, that is Fs, is less than or equals to 0. Static friction is less than or equals to 0. And static friction is also less than or equals to the limiting friction. Limiting friction is also equals to what? Less than or equals to limiting friction. You can see. Varies, not constant. Not constant. Variable. That is, static friction is less than or equals to 0. Can be 0. Okay? And also less than or equals to the limiting frictional force. Less than or equals to the limiting frictional force. The third one now. Force, the limiting frictional force is directly proportional to the normal. To what? To the normal. This is very important. Very important. Very important. Very important. Limiting frictional force is proportional to where? To the normal reaction. To the normal reaction. We use one limiting friction. And take note that it is not what? Fs. That is static friction, not this, but limiting friction. Why? Because it's what? It's not constant. Not constant. Not Fs, but Fl. Limiting friction, not constant. It varies. That's why we call it what? Variable. Variable. That is, the static friction is when the tendency of the body the tendency of relative motion is there. That is rest. Variable. Okay? That is Fx is less than or equals to 0 and is less than or equals to what? The limiting frictional force. FL is proportional to what? To the normal reaction. Normal reaction. That is N. Normal reaction. Some textbook we use R. R stand for what? Reaction, or N. Normal reaction. Normal reaction. F of limiting. Very, very important. And not this. Not Fs. Take note. Take note. Why? Just because this is not what? Constant. Okay? It can be what? More than this. Cannot be what? More than the limiting friction. But it can be equals to the limiting friction or less than the what? Limiting friction. So you can see that this is not what? Constant. So that's the reason why we're not using what? Fx. But Fl. Take note. Okay? From here we know that to remove this guy we can have Fl is equals to mu s times the normal reaction. Fl, that's the limiting friction, equals to Ux, that is mu s. This is what we call what? This is the normal reaction. This is constant. What is constant. It's very, very constant. Very constant. It's constant. Which is called what? Coefficient. Coefficient. Coefficient of static friction. Coefficient of static friction. The coefficient of static friction is constant. And you know, in order to remove this, you apply this, an equality sign. To remove the proportionality sign. Take it. Take it. Alright. Kinetic or dynamic friction. Dynamic friction. Kinetic or dynamic friction. This is when the relative motion is what? Is there. When the relative motion is there. Or we can say what? Is the force required for the body to move with a uniform speed. Okay? Example of that is your rotation motion. Rotation motion. Rotation motion. Secondly, is what? Is constant. 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 Unlike what? The static friction, that what? FL is not what? Constant. It's not. It varies. Okay? That is FK, that is static kinetic friction. Kinetic friction. This is limiting friction. Kinetic friction is what? Is constant. 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 Very, very constant. Okay? The third one is what? Is FK, that is the kinetic or the dynamic friction is proportional to the normal reaction. Very, very important. Very important. Very important. Is proportional to the normal reaction. Okay? So we can have FK equals to what? Mu K n. Where this is what? Coefficient of kinetic friction, coefficient of kinetic friction. That's UK. Okay. Mu K, mu. That's the name of the symbol. Mu, which we use U to represent it. Okay. It's constant. It's very constant. Constant. We should call it coefficient of kinetic friction. Coefficient of kinetic friction. So from here now we have Fk to be equals to what? Mu x times what? The normal reaction times the normal reaction. Take notes. Question 1. A box of mass 2 kg is pulled with a force of what? A force of 4 Newton. This is the ground. That's the ground. Coefficient of kinetic friction, UK. Okay, 0.3. Okay, let's use 0.2. 0.2. Find A. The friction. B. The acceleration of the box. This is box of mass 2 kg. We want to find the acceleration and the friction and the acceleration. And the acceleration. The box is 2 kg. What will be the weight of the box? That's 2g. That's weight, W. Weight equals to mg. Okay? M is what? M is mass. G is constant. That is acceleration what? Due to gravity, which is 10 meters per second square. G equals to 10 meters per second square. Okay? We have the force applied in pulling the box. That's 4 Newton. What will be the normal reaction? This will be the normal reaction of the box, which is what? N. Okay? This will be the what? The frictional force. That's Fr. A relative motion of poles. That's the frictional force. Okay? So from there, we know that the upper forces equals what? The upper force must be equal to the downward force. Yes or no? Or you can have N minus 2G equals to 0. N minus 2G. Or N equals to 2G. Take note. N equals to 2G. And recall that what? That we have Fk equals what? Equals to UK times what? The normal reaction. Times the normal reaction. There was UK. That's coefficient of what? Kinetic friction. That is 0.2 times 2 times G. That's what? 0.2 times 2 times 10. This cancel this. 2 times 2, that's 4 Newton. That's 4 Newton. Meaning that this is 4 Newton. 4 Newton. That will be the what? The limiting friction, which is 4 Newton, Fk. 4 Newton. What does that mean? It means that this is what? Static. The body will not want to move. The body will not want to move. Yes, it's static. Because the force applied is equal to what? To this. So this is what? Limiting friction. Now static. Static is not moving. That's why I said what? Static friction is what? Is not constant. Not constant. Call it variable. Not constant. Not constant. Variable. Note that what? F applied greater than the F limiting. That's limiting force. Limiting force. Then what will happen? It means that the body is in what? Motion. When the force applied is greater than the limiting force. It's greater than the limiting force. Greater than the limiting force. Let's say for instance that this is 1 Newton or 2 Newton. This body will move. Because the applied force is greater than what? Than the limiting force. Then the body will what? Will move. Or the box will move. But since it's not what? Greater than, but what? Or equals to, that's 4a. Equals to, this is static. Take note, this is static. Meaning that what? The box will be at what? At rest. Not moving. Because the applied force is equal to what? To the static force. So we can call this one kinetic force. Okay? This is static force because this is equal to this. So the box will still remain what? Same position, not moving. Because this force and this force, you can see 4 Newton equal. So the box will not move. Meaning that this force is what? Is a static force. So since it's not moving, there's no need of looking for what? For acceleration. Taking? So for the body to move, that's motion. To move, the applied force must be what? Greater than the what? The limiting force. Must be greater than the limiting force. But let's say we have this to be what? 2 Newton. This is not what? Static force. This is what? FL. That's the limiting force. Because what? This is greater than this. 4 Newton, 2 Newton. The box will move. But since this is what? We have this to be 10 and this is 20. It will move. That's the limiting force. That's the limiting force. But if you have this to be what? 10 and this is 10, it will not. Because the force applied, that was static force. Static. Means that the box will be at rest. Because the force applied equals to what? When the force applied force equal to what? To force what? Fx. That is the static frictional force. It means that the body will remain at where? At rest. Take notes. Take notes. Question 2. Question 2. Question 2. One shot 4 kg. 4 kilogram. pull. So force of 10 root 2. 10 root 2 Newton. At an angle of what? It's an angle of 45 degrees. Of 45 degrees. It's an angle of 45 degrees to the horizontal. To the horizontal. Let's take this UK. That's the coefficient of kinetic friction, that's UK, to be 0.2. No, let's take it to be 0.3. That's no unit. That's no unit. Take note. That's no unit. Okay? A. Find the friction. B. The acceleration. The acceleration. The acceleration. Acceleration. Okay? Acceleration is a vector quantity. Yes. That's magnitude and direction. So it's a vector quantity. Find the acceleration. We have the box. Let's have the diagram. A box of what? Of 4 kg. It means that the ground is rough. The ground is rough. Meaning that there will be what? Friction. That's 0.3. We have the normal reaction. That is N. Okay. That's 4G. This will be what? The friction. This is the applied what? Applied force. The applied force is not 10 Newton. Okay? It's not 10 root 3. Just like you have something like this, you can look for what? For the vertical component and the horizontal component. Vertical component and horizontal component. Don't forget that vertical component, that will be what? You know, this is F equals to this. That will be F sine what? Sine theta. Okay? Horizontal will be F cos what? Cos theta. Alright? What's sine theta? Sine 45. That's 1 over root 2. Yes. 1 over root 2. Look at it. Is 45. Is root 2. 1 sine. Opposite over 10 root 2 times 1 over root 2. This and this will go. Okay? So the vertical what? That's 10 Newton. Then this will be what? 10 Newton. 10 Newton. Okay? 10 Newton. What about this? This will give us what? Horizontal components. That's F cos theta. That will be 10 root 2 times cos 45 degree. Adjacent by hypotenuse. 1 over root 2. This and this will go. That gives what? 10 Newton. Okay. This is equals to 10 Newton. From there, we know that N plus 1, that's normal reaction plus 10, facing the same direction, must be equals to what? Mg. That is 4G. 4G. So this will be N equals to 4G minus 10. That will change to minus, which is equals to 4 times 10 G. 10 meter per second square. 10 meter per second square. Minus 10. That will give you 40 minus 10 equals what? Equals 30. 30 Newton. 30 Newton. 30 Newton. Then what will be the what? The friction. The friction will be what? Recall that what? That the frictional force is what? Is equals to normal reaction times what? Mu K, that is Fk, okay? Which is equals to, what's the normal reaction? N is 30. 30 times 0.3. Chicken. That's 3 times 3. That's 9. So this is 9. So since this is 9, this is 9. 9. So this is what? The limiting what? Friction. Okay? Going to move. You can see 9 Newton is not up to 10, so it will move. That is movement. Don't forget that F applied is equals to this motion. F applied greater than the limiting force. Limiting force. The body will move. Then what will be the acceleration? Acceleration, since the what? Since the applied force is greater than the limiting force, which is 10 Newton, then it will move towards this side. That will be the acceleration. We have the F, L to be 9 Newton. This is 4 kg. 4 kg. So we can say what? F minus minus frictional force equals to M times A. That's acceleration. F is what? 10 minus 9 equals to 4A. That's 1 equals to 4 what? 4A. So A equals to 1 over 4. That gives you 0.25 meter per second squared. That's acceleration. Okay? Find the frictional force, resolve it horizontally into what? Horizontal components and vertical components. So that will give us F sin theta, which is equals to 10 Newton. This is also 10 Newton. Okay? 10 Newton. So from there, we can have N plus 10 equals to 4G. N plus 10 equals to 4G. So that will be 4G. G is what? 10. Acceleration due to what? To gravity. That will be 4 times 10, that is 40. 40 minus 10 is 30. 30. So we have F equals to what? N times what? Times UK. Okay? That will be 30 times 0.3. This is 0.3. So Fn equals to what? 9 what? 9 Newton. That's 3 times 3 is 9. So that will be what? The limiting frictional force. Because this is what is less than, is greater than this. 10 is greater than that. So the body will what? Will move. There will be movement or motion. As motion. From there, we can do forward for the acceleration. That will be what? 10 minus this equals to mass times what? Times A. 10 minus this, that will be 10 minus 9, that's 1, equals to 4 times A, that is 4A. Divide 2 by what? By 4. 1 divided by 4 equals to 0.25 meter per second squared. Taking. Okay? Now try this. Try this. Try this. Try this. 70 kg. Force of 20√3 an angle of what? Of 37 degrees. 37 degrees. An angle of 37 degrees to the horizontal. Find. There. A. Find the A. Frictional force. B. Acceleration. You can send the answer. Thank you and God bless you.